Okay, so for this week, we're going over section 7.2 in the book, where we're looking at sum and difference formulas for the three primary trig functions, sine, cos, tan. We're going to start with sine today. We'll do cos tomorrow. We'll do tangent on Wednesday. So I'm going to pop the equations up there, and then we're going to look at one possible example where these equations might be helpful. Yeah. So for sine, if I have sine of angle alpha plus angle beta, Greek letters for angle measures, English letters for points and lines. Alpha looks like the little Jesus fish, beta looks like a B but kind of curly. Yeah. You can use A and B if you can't write alpha and beta. Equals sine of alpha times cosine of beta plus sine of beta times cosine of alpha. Do I expect you have that memorized? Heck no. I just had to open the textbook up to look at it. I don't remember what it is. And I've been doing this a lot longer. So it's not do you have it memorized, it's can you use it. So sine of angle A plus B is sine A cos B plus sine B cos A. The one before B, where? Alpha. Alpha and beta, or A and B if you don't like alpha and beta. Any guesses how the formula change if we're subtracting those angles? And the answer is the only change is that the addition becomes subtraction. Sine is nice that way. And these are one of these things that would go on your note page or that would be on an equation sheet that I gave you. Again, I don't want you to memorize it. And there are a couple of instances where this is helpful. One of them, if you're doing things like physics or engineering, sometimes you're calculating the sine of a difference in angles, and it's easier to evaluate by separating it into two separate expressions. The other example is the one we're going to tackle, which is what happens when I'm asked to find an exact answer of an angle that I don't have on the unit circle. For example, what if I want to know what sine of 75 degrees is? If you pull up that unit circle that we were working with, the three angles in quadrant 1 were 30, 45, and 60. 75 was not on that list. We don't have an ordered pair that goes with theta equals 75. If I can rewrite 75 as the sum of two of those angles I know the coordinates for, I can find the exact answer even though this angle's not on the unit circle. I happen to know sine of 75 is 45 plus 30. Pretty sure that works out to 75. Check my math. It's been a rough day. But 45 plus 30 is 70, yes? 30 and 45 were two of the three angles that make up that first quadrant unit circle. We have exact values for those. So I'm going to rewrite this using the sum formula, and then I'm going to evaluate those sines and cosines using the unit circle. So first, the formula. The sum formula says sine of the first angle times cosine of the second angle plus sine of the second times cosine of the first. And to evaluate that, we just look at our unit circle. So I'm going to draw a little first quadrant picture. Yeah. I know 45 is the halfway point. I'm going to cut this in half right here. I know that's 45 degrees. And I know at 45 degrees, sine and cos are equal. They should both be root 2 over 2. So that gives me the sine and cos of 45. The next one I need is 30. 30 is smaller than 45. 30 is going to be about here. And the question is, what are the x and y coordinates at 30 degrees? Square root of 3 over 2, 1/2. Very good. Very good. 3, 2, 1 for the x coordinates, 1, 2, 3 for the y coordinates. Very good. And the last reminder, when we're looking at points on the coordinate plane, yeah, points on that unit circle, x is cosine, y is sine. So now we're just going to plug those in. So sine of 45 is the y coordinate at 45, which is root 2 over 2. And then cosine of 30, that's the x coordinate at 30. Just square root of 3 over 2, perfect. Plus, and then the two fractions, sine of 30, that's the y coordinate at 30, which is 1/2. Cosine of 45 is the x coordinate at 45, which is root 2 over 2. That's all the trig. Now it's just a little bit of math magic to make those fractions prettier. When we multiply fractions, we multiply across the numerators, we multiply across the denominators. So for that first term, root 2 times root 3, 2 times 3 is 6, so root 6. In the denominator, 2 times 2 is 4, happy face. Next fraction, 1 times root 2 is root 2. In the denominator, 2 times 2 is 4. And if you want to be a proper fancy pants mathematician, you write that as a single fraction, square root of 6 plus square root of 2 over 4. That wouldn't have come from the unit circle. There would be no way that we could easily find that looking at the unit circle. That would have taken a lot of work. But if I can split the angle that's inside that sine up into two smaller angles that I know the answers to, I can use the sum or difference formula to help me find the exact answer. The first part of your delta math for this week is practice doing that with sines and with cosines. We did sine today. We're going to do cos tomorrow. We'll talk about tangent and cofunctions on Wednesday. Yeah.